guys, Her Majesty took away my fear I had in chemistry and biology. You have to join the easy words. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the easy word. Be a subscriber. Bye. Thank me later.
Hello, this is Her Majesty Easy Word Science channel. In this video, we'll be handling the Majestic Guide on the analysis of lead 2000 nitrate 5 salts as sample C and iron 3 chloride as sample D. These are the likely questions, so I will provide their answers at the explanation needed. You see what the question says on the screen, that C is an inorganic salt, D is a soluble chloride. Carry out the following exercises on C, and D, record your observation and the conclusion drawn from the test. Identify any gas or gases involved. Okay, so I'll follow the instruction, and let's make table first. Remember, we have to have test, observation, and inference on our table. So our table, yeah, we got a ruler. Okay. Maybe that's too wide. This should be our serial number. Observation. For the likely question 1, the A says dissolve C and D separately each, so you will be told to dissolve both, so there will be sample C plus 5 cm cube distilled water plus stir, then plus litmus, of course, this is maybe 1A. So we have also sample D plus 5.0 cm cube distilled water plus stir plus litmus. They are all possible, so whereby we can subject ourselves to dividing this into maybe 2. So what should be? C is lead nitrate, of course, it will dissolve. So C, first of all, you say does what? C dissolves fully to form a clear solution turned, because on hydrolysis the solution of lead nitrate will behave as an acid because it's a salt of weak base and strong acid. Solution definitely will turn, and that is turn blue, litmus paper red. Your inference will be sample C is soluble. Solution of C is acidic. Got that? So we come to the second part, exactly the same thing, but it's not going to be a clear solution. Remember, D, okay, the line was a wrong ruling. I didn't rule where I suppose. This line should be somewhere here. Yeah, sample D plus, this time around is going to give us brown solution. D dissolves to form brown solution or reddish brown. Solution. It will also turn blue litmus red. Well, you might find it difficult to notice that because of the brown color, but that's the same thing that will happen. Solution of D turns blue litmus red. The same thing you report here. So because it's the same, just same. But in exam you don't mark this too good. I want to save time. The next one is to the first portion of C add C. Though the question, okay, they say test with litmus. I was correct. That's the question. I remember this is likely question. So when you go into the examination hall, please listen and follow the instructions well. To the second portion of C, add aqueous ammonia. Okay, add sodium hydroxide in drops and in excess. We now have first portion of C. So we have first portion of C. We might maybe to contrast the colors. So the BI is first portion of solution C plus NaOH in drops plus excess. So definitely we are talking about lead reacting with sodium hydroxide. It will give us white chalky precipitate, or you can say PPT, formed in drops. Precipitate dissolved in excess or soluble in excess. What's your inference? Since it's powdery, no need of putting aluminium here. Lead 2 likely because it dissolved. Remember, calcium will form but it will not dissolve. But since it dissolves, it's going to be lead 2 ion likely. Okay, then the other one say the same thing, we add sodium hydroxide this time around. Second portion of, remember they might start with the ammonia one first. Second portion of sample C solution plus aqueous ammonia. Please put aqueous. In drops plus excess. You have white chalky or powdery. Remember, anyway you say chalky, you can say powdery. Precipitate, PPT formed. Precipitates remained insoluble. Precipitate persists in excess. Persists or remained insoluble in excess of what? Ammonia. You will use this ammonia first, likely. Yeah, please, the ammonia will come first before the sodium hydroxide, so that with the ammonia, although since it's powdery, there is no need of putting aluminium there. It doesn't make any sense. So you still go on and still write the lead 2 likely or present. Then the next question says, they say now mix the third portion of C with the first portion of after adding aqueous ammonia. You have to mix portions of C and D. You have to divide into parts as you are instructed. Okay, so this time around, that's where the double decomposition reaction will take place. So the next one is third portion of C plus first portion of solution D, what will happen? There will be white powdery precipitate still. Then plus, after you'll be told to add excess, okay, there will be heat and allowed to cool, followed by heat and cool. I think it's there in the question. I should have supposed to have added it. Okay, please, third portion and D, please, there will be I, you are required to heat and allowed to cool there, please. So there will be white powdery, which is the same thing as chalky. This time around, not in drops again. White powdery precipitates, which dissolves on heating and reappears on cooling. Reappears on cooling. So this time around is double the composition that is taking place. Anything, because the question I've told you that is a soluble chloride, D is already a soluble chloride. So since it contains the chloride ion and they add it to sample, we are using D now to find C, because the question has made it clear that it is a soluble chloride. D is a sample of soluble chloride. If you look at that question well, so we are now using a chloride to check for lead-2 ion. Since this happens, it automatically confirms lead-2 ion confirmed, because the compound formed according to the equation of the reaction you can see here is a lead-2 chloride, which is solid, is insoluble, but that's double the composition. You see aqueous reacting together to give us solid and aqueous. The precipitate is lead-2 chloride. In practical, the precipitate will take time to form. If you mix the two, it won't be so fast. It will take gradual process before it will form. But on heating it, it will cool. It will disappear, meaning it dissolves, because lead-2 chloride is soluble in hot water but insoluble in cold water. So the next one says, to the second portion of D, add sodium hydroxide in the excess. They are now testing for ion 3 ion. And then in test for ion 3 ion, you need 3 possible reagents to test for ion 3 ion. These reagents are actually sodium hydroxide. The possible thing we need in the test, we have sodium hydroxide. You can equally use aqueous ammonia, or you use potassium hexacyanoferrate 2. If you are testing for ion 3, you need the ferrate. This is the ferrate 2. But in the sometimes I think the thing follower sent to me, they gave us ferrate 3. So we will assume it is no mistake, and this is formula for ferrate 3, K3Fe cyanide ion bracket 6. So this one on the screen that I did not clean is what we were asked to provide, but you don't use this actually to test for ion 3 because it's already ion 3. So but I've tested the experiment. Just know sodium hydroxide, aqueous ammonia are used to confirm the presence of ion 3 ion, but the most reliable is using potassium thiocyanate KCN, or you can equally use potassium hexacyanoferrate 2, that's K4Fe, but they said ferrate 3 in the specimen they provided, so we work with ferrate 3. I've done the experiment on both cases. I'll give you the reports. So can I adjust this? So in the test for ion 3, that's the option here, says to the second portion of the add sodium hydroxide in drops and in excess. So sodium hydroxide we are now adding to ion 3 chloride. So we have sample D, or second portion of solution D plus sodium hydroxide in drops plus excess what you get is reddish brown gelatinous precipitate. Though the iron 3 chloride is already brown, but you see a precipitate, insoluble particle, which is also reddish brown. Reddish brown precipitate formed in drops and insoluble in excess. So what do you write? Iron 3 ion present. So then to the third portion, we were also told to do the same but with sodium hydroxide plus but with aqueous ammonia, please. So there will still be the same results. Reddish brown in drops, please, plus excess. Reddish brown in drops is you just add just few drop, 2 drops or 3. Then in excess you just pour to make sure to check whether the precipitate formed dissolves or persists. So reddish brown gelatinous, I didn't put it here. Reddish brown, please, is gelatinous. Reddish brown gelatinous precipitate formed, which persists in excess. You can still say iron 3 present or likely. Then the next question, we were instructed to add I mixed it up. From the question here, he said that K, I wrote K3 here, but the one they provided is K4FE. That's the one we are required to do. So second portion is not soda hydroxide. Okay, yeah. The BI, I say soda hydroxide / ammonia. So we reported you are going to get the same results with both aqueous ammonia and sodium hydroxide. Then the other one says second portion, you add potassium hexacyanoferrate 3. This is already iron 3, so adding iron 3 again to it, I know my practical showed me green, because the KCl, you just say solution D plus K4Fe. I'm looking at as if it's a mistake, but let's work with what they provided. This is K3. Let me work with what they provided. K3. In practical, if it is hexacyanoferrate 3, the hexacyanoferrate 3 itself is yellow actually, while the iron 3 is brown or reddish brown, as you can see down the screen. So but when you add a ferrate 3 to iron 3, still that's iron 3. Remember the ferrate 3, ferrium is still iron 3. I observed what there is a formation of a green solution, formation of a greenish or dark greenish solution. For inference, I will not be biased. I don't know what should be reported. We don't test iron 3 using iron 3, to my little knowledge. If you are testing for iron 3 ion, you use hexacyanoferrate 2, which is green already, and it will turn blue now. So I wouldn't know what to report here, but let's assume that what they said is solution D plus potassium hexacyanoferrate 2 and not ferrate 3. The correct thing is formation, there is formation of a deep blue solution. Formation of deep blue solution, and this automatically confirms iron 3. Yeah, since we already know that what we are holding is ferrate 2, it forms anything that helps it form deep blue solution is iron 3 ion. So for the second likely question, they said dissolve C separately about 5 cm, just the same pattern. Divide into 3 portions. First portion of D plus sodium hydroxide. D is iron 3 chloride. Yes, so it's the same thing we got in BI above. So you still have the same reports like we did here. That question is similar to what we are going to observe at this point. For D, that is over here. See here now. This place is highlighted. Yeah. So this is exactly the same thing. So we go back and see the next question. The B, the second portion of it says, second portion of solution D, add K4. I was still writing K4, but what they provide, okay, slash K3. So the same result. If they insist in the exam, if it is ferrate 3 that they will use in the question paper, just report greeny solution formed. Then, but if it is ferrate 2, it will form deep blue solution. Okay. Then if it forms deep blue, you can now have the correctness to say, the courage to say iron 3, iron, confirmed. Then third portion of solution D plus 1 cm of solution C, heat and allowed to cool. Yeah, the same thing we did. So there will be double decomposition reaction. So that's it for the analysis of analysis of lead 2 triazonitrate 5 and then iron 3 chloride. So the only thing there is that test for chloride might not be easy. That's another emphasis. Why are we not looking at test for chloride ion? Test for chloride ion might be not easy approach. Reason is because of, if you do it practically, you wouldn't observe what the thing that is theoretically expected from the results. What I mean is this: if you want to test for chloride ion, actually, maybe let's use yellow. They said we should provide silver nitrate. Fine. If you react silver nitrate with iron 3 chloride, there will be formation of course, white precipitate suspended in brown color of the iron 3 chloride, which is silver chloride. But as the silver chloride is formed, there will also be formation of iron 3 nitrate. Are you seeing it? So the iron 3 ion is still in the solution. Then on adding excess aqueous ammonia, which is expected to test for chloride ion, we add silver nitrate followed by excess aqueous ammonia after adding HNO3 to prevent the precipitation of other insoluble salts. If you add now, see the resulting mixture, the product formed is a silver chloride and iron 3 nitrate. When you now add ammonia in excess of this, the ammonia, some of the ammonia, instead of dissolving the silver chloride, will go and react with the iron 3 ion, giving you reddish brown precipitate. So it's going to be a confusing experiment. If they ask that question, a child is free to say, on adding silver triazonitrate 5, there is formation of white precipitate suspended in brown solution of iron 3. Then on adding aqueous ammonia, instead of saying dissolves in excess, you now say reddish brown precipitate formed, because that is the experiment. I am an analyst. Practically, this is what you will obtain, because I have done them before giving you this guide. So I'm not really expecting that they will be able to ask us to test for chloride ion in this case. Rather, they can use that same iron 3 chloride to test for lead 2 ion, like we showed you previously. But even using the lead to test for that chloride ion is not going to be easy, because if you add that lead, there will be formation of white precipitate. That one is is easy. They can use, yes, please, they can use that lead too. They can use sample C to confirm chloride from sample D. Reason is that if the question tell you that C is a lead 2 salt, watch this question. Look at that number. You see that likely question to say that C is a soluble lead 2. They have called lead 2 now. So coming to III, they say third portion of D plus solution of C. Therefore, they have mentioned lead 2. They are now using lead 2 to find ion, a chloride ion. That's the only possible way. What will happen here? The only variation here is that the other one we were using chloride ion to confirm lead in likely question 1. But in likely question 2, in question BIII, we are now using lead to confirm chloride ion. Do you get that now? So if in your report in third portion, that's likely question 2 III, BIII, what we are going to observe there is that there will be still white powdery precipitate which dissolves on heating and reappear on cooling. But using silver nitrate and aqueous ammonia to confirm ion, to confirm chloride ion here is going to be very difficult. It's going to have confusing results. So if there will be tests for chloride ion, they might have told you that C is a lead 2 compound. That's the only way. So that when they now tell you add C to the D and heat and allow to cool, we are now known of lead 2, so that this compound will form, which is soluble in hot water and insoluble in cold water. But when they mention chloride ion without telling you what D is, we now use this chloride to now confirm the lead. So that's it. Please subscribe and share my video. I cannot do without you. Best of luck in your exam. Much love.
Hi, I wanted to tell you that you can contact Her Majesty World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty's World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.